Hello everyone. Today I'm going to be demonstrating our tool Jog, which is a Java framework for automatically generating compiler passes and their corresponding tests for people optimizations for the hotspot Java compiler from patterns. So, what is a people optimization? Let's consider an example Java program. In this sample Java program, we have a static method add7 that takes 3 long arguments and returns their algebraic expression. This method is invoked with the values 1, 1, and 1. The program is first compiled down to bytecode using the Java C compiler, which is then executed and also simultaneously optimized by the JVM using the JIT compiler to generate the output 0. Going back to our example Java program, the compiler could have instead been instructed to replace the returning algebraic expression a minus b plus b minus c with the more simplistic expression a minus c, which is more efficient. This class of compiler optimization that examines adjacent codes of instructions to make targeted changes to improve the speed of execution or reduce code size are known as people optimizations. Thus, every people optimization requires an input pattern and its corresponding output optimized expression. Now let's look at the overview of Jog. Jog provides API functions before and after, which lets developers write the input pattern and their corresponding optimized expression. Jog then uses the extended abstract syntax tree of the pattern and the optimized expression to generate compiler passes for the people optimization in C and C++, and correspondingly it generates IR tests in Java to test the compiler passes. Furthermore, Jog is capable of detecting shadow relations between the specified people optimizations. This means that if a pattern matches 2 specified people optimization, then the compiler pass for one of them may be unreachable, and Jog will signal this to the developer. Now let's demonstrate Jog. We will first navigate to the Jog directory and execute the install script to build Jog. Once built, we are going to take a look at how Jog's APIs can be used to write patterns. So here in the example.java file, we have 2 patterns, add2 and add7, where the before API function is used to specify the pattern and the after API function to specify the optimized expression, and the same for the add7 pattern. Now let's go ahead and generate the compiler pass as well as the IR test for this example. We see that the compiler passes are generated in the directory GenCode, whereas the IR tests are present in GenTests. And in this case, add2 does shadow add7, so Jog shows a warning message. Now let's take a look at the generated compiler pass in C++ by going to the GenCode directory. So here we see the compiler passes for the 2 patterns that we specified in example.java, add2 and add7. This C++ code block can then be copied into the source file for the corresponding optimization node in hotspot compiler to ensure that the hotspot compiler supports the specified people optimization. Similarly, we can see the IR test that has been generated by going to the GenTest directory. Here we see tests for the 2 patterns that we specified, add2 and add7. We now go to the directory which contains OpenJDK and run the generated IR test using JTReg. In this case, we have commented out the test for pattern add7 since add2 shadows add7 and the test would otherwise fail. The list of pull requests opened using Jog against OpenJDK and other documentation can be found on our GitHub repository. Thank you.